Our planet is home to over 7 billion people today, with tens of millions being born and passing away each year. Every one of us leaves behind traces of our existence in the air, in the water, and in the soil of the earth. However, these traces won't last forever. Buildings will crumble within a few hundred years, and even the most resilient materials like stone, plastic, or nuclear waste will eventually degrade, given enough time. So, how can we be certain that we're the first advanced civilization to inhabit Earth? According to the Silurian Hypothesis, maybe we can't be so sure. Let us explore this fascinating idea. A big thanks to Shopify for sponsoring this video. If you're ready to take your business to the next level, click the link below and start your free trial today. The Silurian Hypothesis presents an intriguing thought. It suggests the possibility that advanced, intelligent, reptilian, humanoid-looking beings could have had a vast civilization on Earth that could have existed long before humans, potentially leaving behind little to no trace, due to the passage of mega-annums. Imagine a civilization as advanced as ours, or even more so, thriving millions of years ago. Over such vast expanses of time, natural processes like erosion, tectonic activity, and other geological changes could erase almost all evidence of their existence. This hypothesis challenges our understanding of Earth's history and the development of intelligent life. It also raises questions about the longevity and resilience of civilizations and whether we might one day face a similar fate. If such a civilization did exist, what kind of technology might they have developed? Could they have achieved space travel or even left the planet entirely? There are even some accounts of intelligent reptilian beings living within the Earth, in natural vast cavern systems deep within the Earth's surface. Be on the lookout for a video on that soon. But these are questions that spark the imagination and drive scientific inquiry. Researchers are now looking for subtle clues in the geological record, such as unusual isotopic ratios or unexplained anomalies that might hint at past advanced civilizations. The search is meticulous and requires a deep understanding of both geology and archaeology. While the Silurian Hypothesis remains speculative, it opens up fascinating possibilities about our planet's past. It encourages us to think beyond the conventional timeline of human history and consider the broader context of past life on Earth. We humans have only been on this Earth for about 200,000 years, a mere blink of an eye compared to the vast expanse of time complex multicellular life has inhabited this Earth. Ultimately, the Silurian Hypothesis is a reminder of the vastness of time and the potential for countless untold stories hidden within our planet's ancient past. It invites us to keep exploring, questioning, and seeking out the mysteries that lie beneath our feet. When scientists Adam Frank and Gavin Schmidt proposed the Silurian Hypothesis, they raised thought-provoking questions about our ability to uncover the distant past. We typically study ancient civilizations by examining artifacts and ruins, but that approach only works for recent history, going back a few thousand years. However, when we attempt to look millions of years into the past, the challenge becomes significantly greater. For instance, although Earth is about 4.5 billion years old, and complex life emerged roughly 600 million years ago, the oldest land surface that we've found is only around 1.8 million years old, located in the Negev Desert in Israel. This is particularly striking when you consider that dinosaurs roamed the Earth for approximately 165 million years, yet we've only discovered a tiny fraction of their fossils, less than 1% of all dinosaur species, and fully complete skeletons are virtually non-existent, with only a handful of near-complete skeletons ever found. If so much of our planet's history has eroded away or been buried, what else might we be missing? One way to define a civilization, according to the Silurian hypothesis, is by its global industrialization, a process that leaves lasting clues. Our modern industrial activities are altering the planet in ways that could be detectable for millions of years. Over time, our entire era might be compressed into a thin layer of sedimentary rock, leaving a subtle but significant mark on Earth's geological record. This era, often referred to as the Anthropocene, could be identified by future scientists through changes in the chemical makeup of rock layers. For example, our large-scale agricultural practices are significantly altering the planet's nitrogen cycle. This change leaves a distinct isotopic signature that could be preserved in the Earth's sediment layers. Additionally, human activities like deforestation and mining are increasing soil erosion and adding metals like lead, chromium and gold to the environment. These elements might be detectable in the rock layers formed long after our civilization has vanished. But the most telling marker of an industrial civilization is carbon. The use of fossil fuels has significantly altered the carbon isotopic ratios in our atmosphere, a phenomenon known as the Suez effect. Carbon has several isotopes, but the most common are carbon-12, carbon-13 and carbon-14. Plants prefer carbon-12 during photosynthesis, and as fossil fuels, which are derived from ancient plant material, are burned, the levels of carbon-13 and carbon-14 decrease while carbon-12 levels increase. This shift in carbon ratios, along with the warming effect on the planet, could be a key indicator of industrial activity detectable in the distant future. While the debate about the causes of climate change continues, what's undeniable is the increase in global temperatures. When examining sedimentary layers from millions of years ago, scientists might look for a temporary spike in carbon and oxygen levels, along with increased metal concentrations and a rise in global temperature. Finding such a pattern could suggest the presence of an ancient past civilization. Interestingly, there is evidence of such changes in the geological record from about 56 million years ago, during what is known as the Paleocene-Eocene thermal maximum, or PETM. During the PTM, Earth's temperature rose dramatically, leading to a significantly warmer climate where even the polar regions were ice-free. This period saw a significant shift in the planet's climate, with tropical conditions extending much further than they do today. But is the PETM evidence of an ancient civilization? It is definitely a possibility. Some researchers have speculated that such a dramatic change in climate could have been influenced by an advanced civilization, though this remains highly controversial. It took thousands of years for carbon levels to rise during the PETM, whereas we've seen a comparable increase in atmospheric CO2 within just a few centuries. This rapid increase in carbon levels today is often contrasted with the slower, more gradual changes observed millions of years ago. The most likely explanation for the Paleocene-Eocene thermal maximum is a massive volcanic eruption, though the exact cause remains a mystery. Volcanic activity could have released vast amounts of greenhouse gases, leading to the warming observed in the geological record. Still, the presence of fossil carbon during this period hints at significant changes in the environment, possibly from natural processes, but intriguing nonetheless. The Paleocene-Eocene thermal maximum remains one of the most fascinating and mysterious periods in Earth's history, offering clues to both our past and our potential future. The Drake equation is a well-known formula used to estimate the number of extraterrestrial civilizations in our galaxy. It considers factors like the number of stars with planets, the likelihood of those planets supporting life, and the chances of life developing intelligence. Estimates vary widely, but there could be anywhere from 150,000 to 1.5 billion civilizations in our galaxy. What's particularly interesting is that if life can arise more than once on a planet, as the Silurian hypothesis suggests, then intelligent civilizations could have existed on the same planet multiple times over millions or billions of years. This idea not only applies to distant exoplanets, but also raises questions about our own solar system. Mars, for instance, was once much warmer and wetter, and so was Venus. Even Europa, one of Jupiter's moons, has a subsurface ocean that could potentially harbor life. Interestingly, according to a remote viewer, if you're inclined to believe in such phenomena, he claims to have seen octopus-like creatures inhabiting the oceans of Europa. A very interesting claim, considering octopi are drastically different than most known species in our oceans. An episode on Europa is coming soon, so keep an eye out for that. But as we begin to explore these worlds more thoroughly, we might find that while civilizations don't exist there now, they may have in the distant past. The Silurian hypothesis opens up the possibility that life, including intelligent life, might not be unique to any one time or place. Instead, civilizations might have arisen and fallen multiple times across the galaxy. And with the right tools, we might one day be able to find evidence of them. Thank you for watching. If you enjoyed this video or found it thought-provoking, please consider liking, subscribing, and sharing it with others. Your support helps us continue exploring these fascinating topics. Until next time, take care and keep questioning the world around you.